Hi, I would like to take some time to go through pages 63 to 65 with you. If our goal is I can dilate figures on the coordinate plane. So far in the transformations that we've worked with, we have done translations, reflections, and rotations. And all of those, the shapes stayed congruent. Same size, same shape. So it didn't matter if you turned it, flipped it, drug it, like slid it, whatever. They stay the same size and the same shape. For dilations, they are going to stay the same shape, but they're either going to get bigger or they're going to get smaller, depending on what the scale factor is. And when we're looking at this, when you are doing a scale factor of a number bigger than 1, it'll make the thing bigger. If you're doing a scale factor of less than 1, it's going to shrink the shape. And so they will still be the same shape, but they're going to be different sizes. And your corresponding sides are going to be proportional. So you could set up your 2 equal fractions and cross multiply if you needed to find the lengths of the different sides. To start with all of this, though, let's just look at it mathematically. If we have the ordered pair 4, 8, and we are going to dilate it by a scale factor of 2, basically what you're doing is whatever the scale factor is, you're going to take your x coordinate and your y coordinate and multiply by your scale factor. So the work for this, and I do want you to type it into your notes, but when you're doing things on your worksheet later on this week, you don't need to like put 4 times 2 and 8 times 2 in parentheses. But I do want it on your notebook page so you'll remember when you look back how you found your new coordinates. So basically what this becomes is 4 times 2 is 8, 8 times 2 is 16. So the ordered pair that was at 4, 8 is now going to be at 8, 16. So visualize with me real quick, and we'll do some later. If I had a rectangle and one of the sides were at 4, 8, like right here, and then now it's going to be at 8, 16, you're going to see what's going to happen when you do that to all 4 of them. It's going to get a lot bigger on the coordinate plane. So then now I'm going to have to move my picture here so we can see. It says find the image of negative 12, 9 after dilation of a scale factor of 1/3. So now when we're looking at this, we are, it's less than 1, and so it's going to take it and it's going to shrink it. So basically what the work would look like for this is you could either say 12 times 1/3 and then 9 times 1/3. Or when you're multiplying by 1/3, that's the same thing as dividing by 3. So you could also look at it like this: 12 divide by 3, and then our negative 12 divide by 3, and 9 divide by 3. But either way you look at it, your actual answer, what your new ordered pair would be, negative 12 divided by 3 is negative 4. And then, oops, I forgot my parentheses here. And then 9 divided by 3 is 3. So your new point after this dilation will be, you know what, I'm just going to have to shrink the font here. So we'll keep that stuff up there for the work. So your new point would be at negative 4, 3. So again, visualize with me. If you're at negative 12, 9, so you'd be kind of, well, I guess you're looking at me backwards here. So it'd be up here. Then when you shrink it by a scale factor of 1/3, you can see what's going to happen is it's going to take all of those and bring them closer together. The next one says find the image of a negative 2, 8 after a translation of 4 left and 6 down. So this one is kind of refreshing our memory from earlier in our notebook. If you're going to go 4 left, left is going to make it, makes your number smaller. So you're going to want to subtract 4. And then if you're going 6 down, down is also in the negative direction. So you'll want to subtract 6. So now you would have negative 2 minus 4. That's going to give you a negative 6. And then 8 minus 6 gives you a 2. So basically you're taking the point and you're moving it 4 left, 6 down. And then number 4 says find the image 7, 4 after you rotate it 90 degrees counterclockwise. So if we visualize here, I'm going to actually go to a different page, or yeah, I'm going to just come down here and so you can visualize. If you have at 7, 4, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, and you're rotating it counterclockwise, it's going to bring it over here. So what you're looking for is, you know, your x, your new x is going to have to be negative, and your new y is going to be positive since it's in this quadrant. So if you visualize that, really the only thing you have to remember is when you're rotating 90 degrees, you just switch the x and y. So here's what I mean. 7, 4, the first thing I think about is how it's going to be 4, 7. I switch those numbers around. And then when I look at the graph paper, if it was up here to begin with, if I'm going counterclockwise, my x is going to be negative, my y is going to be positive, so then I put the negative. That's how I remember how to do it. If you are spatially, like if I'm sure a lot of you are way better designers than me, and so maybe you could see it. The other way that this is happening is if you're at 7, 4, I think that was here or whatever, it needs to make a right angle with the origin. And so then that's why it works to just flip the two ordered pairs. So then finally, number 5 says the image of -3, -7 reflected over the x-axis. So again, I'm going to come down here to kind of show you. So if I'm at -3, -7, let's see, 1, 2, 3, 4, 5, 6, 7, and I'm going to reflect it along the x-axis, that means I need to take it and I need to flip it up. So if I was 7 down, now I'm going to have to go 7 up. And so it would be there. Now that ordered pair, notice that my x coordinate stayed the same because it stayed on that line, and it's my y coordinate that went to the opposite. So my x coordinate stayed the same and my y coordinate changed. Since it was 7 down from the x-axis, now it's going to be 7 up from the x-axis. Okay, let's look at this one down here. It says dilate triangle A, B, C that have these vertices, and I think that shouldn't say dilate. I think it should say rotate. Sorry about that. So we're going to rotate it 90 degrees counterclockwise. So if we look at A, you have your points over here. Right now, if you just drop it on A, that's at -8, 6. So if you're rotating it 90 degrees counterclockwise, you're going to take it, you're going to flip your coordinates, and then think about what that means. If I'm down here, because it's going to 90 degrees counterclockwise, which means it'll be in this quadrant, both of my things will need to be negative. And so what I do is I flip them, make it 6, 8, and then I know since I'm going to this coordinate, both of them need to be negative. So 1, 2, 3, 4, 5, 6. I'm going to drop it so I can scroll down here. And then 1, 2, 3, 4, 5, 6, 7, down here. Okay, I'll just move this up. That'll help. And then B is at 0, -4 right now. So it's right here. So again, I'm going to flip them. And so I know it'll be 4, 0. But then think about B is going in this direction over here. And so that is going to make it at 4, 0. So you're just going to move it one quadrant to the left because it's counterclockwise. And then, do I not have another point? I can't find my other point. So copy and paste. Sorry, I have no idea why this is what I'm doing to make this happen, but I'm sure I'm doing something. Did I just lose my point? Oh my goodness. Okay. I'm on the wrong page. Okay, I'm going to pause my video so I can figure out where my dot went. Okay, I think I'm back here now, and hopefully you can see this. So I found my dot. It was down here, and anyway, I got it fixed. So I have it up here at C right now. C is at 8, 6. So thinking about what that means counterclockwise means it needs to come over here where my new x is going to be negative and my new y is going to be positive. And so when I'm looking here, once I flip them, I'm going to go 6 this way, 3, 4, 5, 6, and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you will see that it took that triangle and turned it on its side. There are lines over here, so feel free to like click and drag those to size them. But I'm going to let you do that, and I will see you on page 64.